Hello and welcome to Sasol's webinar Performance Benefits of Using Fischer-Tropsch and Microcrystalline Waxes in Powder Coatings. My name is Sinan von Franzinski and I'm Sales Manager of Sasol Wax, responsible for the sales of our waxes into the inks, paints, coatings industry in Europe. Today I have the pleasure to be the moderator of this session. First of all, thanks for joining this exclusive webinar. We are pleased to have you all here with us. A special thanks goes out to those who are joining the second time due to unfortunate technical issues from the last session we experienced. Sorry for that again. Let me give you some guidance before we start with the presentation. This webinar will be recorded. You will receive a recording after the next days after this presentation. This will include all the contents and presentation from today. Second, your microphones are muted. This is on purpose. Nevertheless, we would like to hear from you, of course, all the questions which may arise during this session. We kindly ask you to use the question and answer button within this application. You can put your questions there, and after the presentation, we will present some of them and answer the questions as best as we can. For now, I would like to hand over to my colleague and your presenter of today, Luca Giancini.
Thank you, Sinan. Welcome, everybody. I'm Luca Giancini, Market Development Manager, Inks, Paints and Coating for Sasol in Europe. I joined Sasol around 2 years ago, and I come from different fluoropolymer producer, and I have a chemical background. I live today in Hamburg with my family with 2 children. I will present today the powder coating study that we have done together with an independent study, external institute. And we will present our Fischer-Tropsch waxes and our microcrystalline waxes against a possible other chemistry that are in competition. Let's start the webinar. So a few words on Sasol. Sasol is a global integrated chemicals and energy company. Through our more than 31,000 talent people, we harness our knowledge and experience to integrate sophisticated technology and processes into our world-scale operating facilities. We safely and sustainability source, produce and market a range of high-value product streams in 31 countries, creating superior value for our customers, shareholders, and other stakeholders. Today, I will present, as I mentioned before, Fischer-Tropsch and microcrystalline waxes for powder coatings. I will show you how to improve slip properties, how to improve smoother surface, to induce matting, increase transfer efficiency, and hide degassing. The agenda is like this. So I will present our Fischer-Tropsch and microcrystalline waxes portfolio that we tested in this study. I will present the first technology, so hybrid powder coating epoxy-polyester based formulation. Then a comparison results on slip resistance, transfer efficiency, smoothness, mar resistance. Then an overview of the second technology, HAA cross-linked based formulation. Again, a comparison results on matting, smoothness, degassing, slip resistance, and mar resistance. Then an overview of the third technology, TGIC cross-linked based formulation. And again, a comparison result on melt viscosity, slip resistance, matting, and mar resistance. Then a summary, and of course, a section where I will try to reply to your questions. So please make question. So Sinan will explain you, will read later more or less all the questions. So some words on our Fischer-Tropsch and in general on the Fischer-Tropsch hard wax. Fischer-Tropsch hard wax are synthetic. So have consistent quality for purpose reason in production. They have low level of impurity, so for example, no sulfur, high crystallinity, then N-alkanes with high degree of linearity, low viscosity, are hard, so they have a very low penetration index, very low surface energy, so that's why also they give hydrophobicity, thermal stability, and excellent lubricant. They have excellent lubricant properties. a smart overview on the wax that I will present today. So we will present micro wax and FTR wax, as I mentioned. So micro wax has very, let's say, medium viscosity, a molecular mass from 600 to 800 Daltons. The crystallinity is low, and the melting is from 55 to 90 degrees. Then Fischer-Tropsch are wax. They have very low viscosity, molecular mass from 750 to 2500 Daltons. Crystallinity is very high, and melting point is around from 80 to 150. This is an overview to explain you difference from example paraffin waxes that Sasol have also, and PE waxes. Here, the portfolio of Sasol wax, Fischer-Tropsch, and Microcrystalline. So an overview of our wax. So you can see H1, you can see different wax. There are, let's say, we can see that there are two type of wax, Fischer-Tropsch and Microcrystalline. We can see that there are different congealing points from 96 to 200, then from 102 to 108, from 80 to 85, the C80 Fischer-Tropsch, 83, 94, the Microcrystalline, and then we have the other micronized powder. So first parameter that will change is the congealing point. Second parameter that will change is the penetration index. The R-wax has a penetration index at 25 degrees below 1. Then we have C80 that is a little bit more softer from 4 to 9. The Microcrystalline from 4 to 10. And then the micronized wax, as I mentioned, that are the micronized powder that come from the H1 and so on. Then the form, we tested pasteurized form, coarse powder, and micronized powder. So overview for the first test. We tested the first technology, hybrid powder coatings, epoxy-polyester based formulation. Here we have a base formulation, a standard formulation. As I mentioned before, Sasol make all these tests in cooperation with an independent external institute that suggests a standard formula with an amount of wax of 1%. That is the standard one. So you can see that there is Crycoat 1626 from Alnex. Is a carboxylated polyester resin, 36.25%. Then Epoxy KD242G that come from Kutco Chemical, that is a standard solid epoxy resin, 36.25%. ResiFlow P67, 1%, that is a flow or leveling agent. Benzoin, 0.5%, is the degassing agent. Blank Fix, 24% is barium sulfate that come from Venator and is an helper of the pigment. Then Black Pearl, 280, that come from Cabot Corporation, 1% is the normal carbon black. And the wax, as I mentioned before, 1%. Some words on our test. So extrusion process. All the formulation are premixed in a Vitamix 3600 blender before extrusion. This is important for you to explain how we have done the test. Then these hybrid powder coating epoxy polyester based formulation are extruded using 90 mm twin screw corrugating APV extruder at a temperature of 100. Then, of course, the flakes are pulverized using a standard benchtop grinder and sieved with a sieved below 106 micron as a D9. Then waxes are incorporated in per-extrusion at 1% and also in post-extrusion at 1%. The dry blended process, waxes are added, as I mentioned before, at 1% also with an high intensity blender. I want to underline that the control that you will see in the results is without the 1% of wax. So our test underlined the different performance based on the wax, not based on other components. Application process, we use an electrostatic spray 2.5 mils using an Ordnance and core gun. And we still on the panels, and then we use an oven for 15 minutes at 200 degrees. So here an overview of the waxes that we use in extruder. 1%, as I mentioned before, Sasol wax H1, H1 and 6, C80, C80G, H105, and the microcrystalline 0907. You can see are all FT except Sasol wax 0907. The melting temperature, before I told you the congealing point, now the melting temperature is 100 for the first two, 80 for the C80, 105 for the H105, and 9394 for the microcrystalline. Then, of course, you can see the form. Someone is pasteurized, someone is coarse powder, and someone is micronized powder. Then we use from competitor LDPE, wax, melting point 110, 118, particle size 10, 12, in micronized form, of course, polypropylene, wax, melting point 160, 170, with particle size from 8 to 12, micronized, of course, modified PE, melting point 140, particle size 9 micron, amide wax, melting point 140, 9 micron as well, micronized, of course, and a blend of PE wax and PTFE, fluoropolymer, with melting point 150 the PE and 325 the PTFE, particle size 2.5 the PE wax and 5.5 the PTFE, and always in micronized powder. This is for extrusion. Post-added, so post-extrusion, we use only micronized powder. Sasol wax spray 30G, Sasol wax spray 30GEF, Sasol wax C80G, Sasol wax spray 105G, Sasol wax spray 105GF. These are coming all from a ground jet mill, are all FT, micronized wax. Then the melting point, you can see 100, 200, the 30 version, 80, the C80G, and 105, the spray 105G and GF. Then from all micronized, as I mentioned, then PE wax, 150, micronized 4.5, 5.5 micron, modified PE is HDPE, in this case, melting point 140, 5 micron, EBS wax, melting point 143, particle size from 3 to 5 micronized, and then PE wax and PTFA blend, as I mentioned before. This is in post-added 1%. Here are the first results. You can see for slip resistance. So the control has a very high value. So for the performance, you need to see the lower value. Sasol in pre-extrusion, Sasol wax 0907 is the microcrystalline wax, achieved the best result, again, in pre-extrusion, and the best results of all Sasol wax. And then, and also respect the other wax that we tested, then follow C80G in pre-extrusion, the micronized with melting 80. For post-extrusion, post-added, so you can see the spray 30G is has the best results. And also, you can see on the right of the test, the blue line, spray 30G achieve the best result in post-added, then also respect the other wax, or you can see also spray 105G that achieve a very good result. So for slip resistance, in pre-extrusion, Sasol wax microcrystalline 0907 or spray 30G. Second option, C80G in pre-extrusion and spray 105G in post-extrusion. Then for transfer efficiency, you need to see the best, the control you can see, the best value is the highest. So in this case, for transfer efficiency, spray 30G, Sasol wax spray 30G achieved the best results. It's a micronized wax, 6 micron. Then they are following spray 105G and Sasol wax C80G. C80G more or less works like EBS. So for transfer efficiency means how much of the product I will spray and how much will finish on the surface. With spray 30G, you can achieve the best results, so means the best transfer efficiency. So for a cost perspective, is very good and save money for you. Then smoothness, again, a pre-extrusion, a post-extrusion test. The control, you need to see the highest value is the best. So C80G achieve, let's say, a good result in pre-extrusion and respect it's quite similar to the modified PE, the HDPE. In post-extrusion, we have Sasol Wax Spray 30G that achieve the best result for Sasol Wax, and also, let's say, similar to Spray 105G, and the best result respect to the competition. So this is for smoothness. Then mar resistance, always in epoxy resin, of course. We have again pre-extrusion and post-extrusion. Mar resistance, so we have in a pre-extrusion Sasol Wax C80G, again is the micronized version of with melting 80. The control, you see the control that has a very low value, so you need to check in this result the highest value. The highest value in pre-extrusion you have with C80G, Fischer-Tropsch. Then in epoxy, and then follow H105, that is a coarse powder of with a melting of 105. Then in post-extrusion, we have Sasol Wax Spray 30G. The blue line you need to see. In post-extrusion, yeah, we have a similar value of amide wax. So again, C80G in pre-extrusion or Spray 30G are the best results from a Sasol Wax perspective. Now, this is a summary for you. For epoxy-polyester hybrid powder coating, we have for improved transfer efficiency, so means saving money, we have the best results Spray 30G, and then the other that follow. For increased slip resistance, we have the Sasol Wax 0907 is the microcrystalline one that we use in pre-extrusion, pasteurized version, and then follow the other micronized wax, so C80G, Spray 30G, Spray 105G. Then for provide smooth coating, we have Sasol Wax C80G, that is the best results from Sasol's perspective, and follow the other. Then for boost mar resistance, we have Sasol Wax C80G as the best result in post-extrusion, so post-added, and then follow H105, coarse powder, Spray 30G, and Spray 105G. So a summary. You can see the summary. I will detail the summary also at the end of this study. This is a summary for epoxy polyester hybrid powder coating resin. Then go in the other test, in the other formulation. So we have the HAA cross-linked formulation. So we have the code 2617 like before with a different weight. I will underline also in this case that this formulation comes from a suggestion from the independent and external institute that Sasol used in cooperation to make this study. So that suggests this free formulation, so the epoxy resin, the HAA cross-linked, and the TGIC, and also the weight, so means the percentage of the difference component, and they suggest the supplier. So code, as I told you before, come from Annex. We have a different percentage respect to the epoxy polyester resin. So we have in this case 68.88%. We have the HAA, that is the resin. The HAA come from Vego Chemical. We have the ResiFlow like before, the benzoin like before, blank fix, same percentage. Black pear 280, that is the cabot carbon black 1%, and again the bauxite 1%. The extrusion process is the same of before. The dry blended process is the same of before, and also the application process is the same. So 15 minutes in the oven at 200 degrees. Let's This is the extruder wax that we use. So Sasol wax H1, H1N6, C80, C80G, H105, and the microcrystalline version Sasol wax 0907. Again, we use LDP, the P wax, the polypropylene wax, the modified PE wax, that is HDPE, the amide wax, and the blend PE wax and PTFE blend. In post-extrusion, this is in pre-extrusion. In post-extrusion, we use similar like before, only micronized powder. So Sasol wax spray 30G, 30GEF, C80G, spray 105G, spray 105GEF. Then we use PE wax, HDPE wax, EBS wax, and the blend PE plus PTFE. Here are the first results. Matting with HAA cross-linked powder coating. You can have matting. You can see the control that has a very high value. In this case, you need to see the lowest value in the test. So with 1% of wax in pre-extrusion, Sasol wax C80G offers matting effect similar to polypropylene wax. So you can see the C80 and polypropylenes as a different value, a similar value. Then of course follow all the other Sasol wax, and amide wax give a quite high value, and of course H1 follow. Then we see the smoothness. Smoothness again in pre-extrusion. You see the control that has a low value. We need to check the highest value. Sasol wax C80G. So again, for someone that joined only now, is the micronized version of Fischer-Tropsch wax with C80 with 80 melting. We have Sasol wax C80G that give us the best value as a smoothness, and then respect Sasol, all the Sasol wax, and respect also the LDPE, the amide, and the LDPE PTFE. Then we have the degassing. With HAA cross-linked powder coating, you can have degassing, and with 1% of wax in pre-extrusion, you can see the control that has a very low value, so means high degassing. You need to check the highest value. In pre-extrusion, you can see that Sasol wax C80G or Sasol wax H1 or Sasol wax H105, more or less, they give you similar degassing, so high degassing, respect to the control, and a modified PE, in this case HDPE, is quite similar to the control, so not so much help for the degassing, and amide wax give a high value. But these tests show you that also Fischer-Tropsch from Sasol help not only for other performance, but help also the system for the degassing in pre-extrusion. Then we come to the slip resistance in HAA cross-linked powder coating. So slip performance you can have in pre-extrusion or in post-extrusion, depend from you, is up to you. So Sasol wax C80G imparts the most slip when added in pre-extrusion. You can see here that the control has a very high value. You need to check the lowest. Then in post-extrusion, we have two options, Sasol wax spray 30G that has the best value, similar to the HDPE, or Sasol wax spray 105GEF that follow for Sasol, and yeah, we have a similar. For Sasol wax spray 30G, we have a similar result respect HDPE and LDPE and PTFE for slip resistance. Then we have the mar resistance. Mar resistance, again, you can see the control. The control has a low value. We need to check in this case the highest value. The highest value come in pre-extrusion for Sasol wax C80G. I can tell you Sasol wax C80G is a very good wax. Then in post-extrusion, again, Sasol-Wax CATG. Sasol-Wax CATG, in this case, we can have in a very good result in mar resistance in HAA cross-linked powder coating in pre and also in post extrusion. In post extrusion, you can see that the HDPE in pre and post extrusion CATG has similar result to HDPE, amide a little bit less. Then, so summary for you, the HAA cross-linked powder coating. In HAA cross-linked powder coating, Sasol-Wax Fischer-Tropsch give you matting, in this case Sasol-Wax CATG, increase film builds without pinoling, again Sasol-Wax CATG, the micronized version, H1 that is pasteurized, H105 that is coarse powder. Then provide smooth coatings, CATG again, H1, H105. Then mar resistance, Sasol-Wax CATG, and improve slip performance, that is inside the Fischer-Tropsch, the slip performance, Sasol-Wax CATG, spray 30G, spray 105G. Depends from you. If you check all these results after this webinar, check if you prefer use in pre-extrusion the box. In this case, you have the option to use pasteurized material or coarse powder. Our coarse powder go from 800 to 1 millimeter, 800 micron to 1 millimeter, or use the micronized version that go from 4.5, in this case, spray 105 GEF, so that means the GEF ultrafine version, or to 6 micron, that is the G version. Let's come to the third technology. Third technology is the TGIC cross-linked formulation. TGIC cross-linked formulation, why we decide to spend time and energy also in this formulation, in this technology, because in Sasol is, as I told you at the beginning, is a global integrated company, and we need to see always globally, and TGIC is used a lot in USA in many customers, so that's why for us it's important to show you the performance also in this technology. You can see here that we change the Crycold is now Crycold 24412, always from Alnex at 67.42%. Then there is, of course, the TGIC. TGIC come from UMC Corporation, 5.08%. ResiFlow P67 is the same like before, 1% is the leveling flow and leveling agent. Benzoin is always there. Blend Fix 24%, like before, is the barium sulfate that help the pigment to performance better. Then Black Pearl 280 Cabot Corporation, as I mentioned before, 1% is the carbon black. Then the box, as I mentioned before, 1%. So Sasol also with this technology use 1% in pre-extrusion and in post-extrusion. The extrusion process is like before for the Epoxy-Polyester technology, for the HAA technology, and for the TGIC technology. The dry blend process is the same, and the application process with the gun is the same gun, and we put the oven at 15 minutes at 200 degrees, like before. Here is the overview of the box that we use in the extrusion. So again, Sasol H1, H1 and 6, C80, H105, and the microcrystalline Sasol 0907. Then you can see pasteurized or coarse powder are the foam. Then LDP, the PE box, the polypropylene box, the HDPE box, and the amide box, all in micronized powder form. Then the post added, you can see all micronized powder as before: Sasol spray 30 GEF, Sasol C80G, Sasol spray 105G, and Sasol spray 105 GEF. FT all in post extrusion, and all micronized powder. Then PE bags, we have PE bags, the HDPE bags, and the blend PE bags and PTFE. Let's see the first test. Melt viscosity is important. The melt viscosity you didn't see in the other with the other technology. With the TGIC is important. Always at 1%. You see the control that has a low value. In this case, you need to check the highest value. So Sasol Wax H105, that is the coarse powder, achieve the best results together with Sasol Wax 0907, that is the microcrystalline wax in pasteurized form. So you can see that they improve the melt viscosity, so improve in this case the viscosity. And then follow the amide. Amide in this case give the best results for the test and respect the control, but as you can see in the some words below the test, Sasol Wax H105 and Sasol Wax, the Fischer-Tropsch, and the Sasol Wax 0907, the microcrystalline one, they can achieve a melt viscosity, but without possible yellowish in the final formula. So this is important for you. This test was done in pre-extrusion. Then we have the slip resistance. Slip resistance, the test was done in pre-extrusion and in post-extrusion. In pre-extrusion, you can see the control that has a very high value, so less slip resistance. The best value is the lowest. You can see in pre-extrusion C80 imparts the best slip resistance, so C80 is in pasteurized form. And then in post-extrusion, you can see Sasol Wax Spray 30 GEF, that is the ultra-fine micronized Fischer-Tropsch with melting 100. Then, of course, follow the PE bags and the HDPE bags. HDPE bags, in this case, Sasol Wax Spray 30 GEF in post-extrusion achieved the best results for all the tests. Respect Sasol Wax and respect PE bags or HDPE or amide. Then we go in metting. Metting is important as well. We can see the control. The control has a very high value. So in this case, you need to check the lowest value. We tested the metting in pre-extrusion and in post-extrusion. In pre-extrusion, we have we tested all the bags that I mentioned before, but C80 and C80G achieve the best results. So you can see here the Sasol Wax C80, so in this case pasteurized form, and also Sasol Wax C80G achieve a very good result. In post-extrusion, we have Sasol Wax Spray 30 GF, again like before, that achieve a nice result. In this case, in pre-extrusion, C80 works similar to PE wax or to the HDPE wax. And in post-extrusion, we have Sasol Wax Spray 30 GEF that is a little bit better respect to the other products. Then go with mar resistance. To improve the mar resistance in TGIC cross-linked powder coating, always at 1%. We tested in pre-extrusion and in post-extrusion. The control has a very low value, so in this case you need to check the highest value. We can achieve a very nice results with H1 and 6 in pre-extrusion, that is the coarse powder of H1, and with C80. C80 is the pasteurized version. We have a similar results like the HDPE micronized. Then in post-extrusion, we have Sasol Wax C80G, the micronized version of C80, that achieve a very high value, so means very high mar resistance. This is important for you. Then follow Sasol Wax Spray 30 GEF, that is the ultra-fine micronized version, a little bit less than C80G. So you can see here in the test that Sasol Wax Spray 30GF and Sasol Wax C80G, they give you a very nice result in post-extrusion. So smart summary: in TGIC cross-linked powder coating, you can achieve with Fischer-Tropsch wax and with microcrystalline wax, you can decrease melt viscosity and allowing greater flow. So means the performance and the improving is in the flowability. You can improve with H105, Sasol Wax H105 is coarse powder, or with Sasol Wax 0907, that is the microcrystalline one. Or you can induce matting, respected polypropylene wax with Sasol Wax C80, pasteurized, C80G, micronized, Sasol Wax Spray 30GF, the ultra fine. You can boost mar resistance with H1 and 6 coarse powder with C80, that is the pasteurized version, with C80G, that is the micronized with melting 80, and Spray 30GF, that is the ultra fine. Then with melting 100, or improve slip performance with the pasteurized version of C80, or with the post-extrusion with post-added, in this case, Spray 30GEF. This is an overview. So here, for you can have an overview with all the tests done, an overview of the Sasol Wax, Fischer-Tropsch, and microcrystalline waxes in powder coating. I want to underline you that all this tested was done on metal, and with the free technology. For someone that didn't listen before, Epoxy-Polyester hybrid. It was the first technology, quite famous in Europe. HAA cross-linked, also used in Europe or in other countries, and TGIC cross-linked, a lot used in USA. All the tested was done in extruded and in post-added. Post-added, of course, we use only micronized waxes. And in extruder, we use, in this case, three kind of form: pasteurized, coarse powder again from 800 micron to 1 millimeter, and micronized from 4.5 to 6 micron. So with matting, you can induce matting in HA cross-linked with C80G, or with TGIC with C80 or C80G. So in this case, I suggest you Sasol Wax C80G, or in post-added in TGIC cross-linked with Sasol Wax Spray 30GEF. Then slip improvement, we have involved all the free technology. You can have They don't.
I need to see the presentation.
So here, guys, thank you for the webinar. Thank you that you participate to the webinar. Now I will leave to Sinan, that probably has some question to read for me.
Hi, Luca. Yeah, first of all, there seems to be disconnection at a certain time, so sorry for that. I hope you all hear us again. Perfect, I see it's working again. Thanks for the messages, colleagues. Yes, Luca, we indeed received a couple of questions. Thank you to the audience being so active. I will now read some of them and also publish them so you can answer them, Luca. So the first question is, why has the test been performed with 1% wax content only?
Yeah, thank you, Sinan. Interesting question. Yes, as I told you at the beginning, Sasol have done this test in cooperation with an independent external institute, and we check a different formulation, and we decided to use as a standard value 1%. So 1%, I know that globally different customers are using a different percentage, but with 1% you can already achieve all these results that I presented today.
Perfect, thanks, Luca. There's another question also concerning the testing. Why adding benzoate when you promote degassing?
Yeah. Interesting question. Yeah, normally benzoate is used for degassing, but if you saw my presentation, our bags reduce the overall viscosity in liquid phase, so with temperature, and this allow for an easy degassing. So means that the wax in this case help to achieve a better degassing. Because the Fischer-Tropsch, as I mentioned at the beginning, my third slide, the Fischer-Tropsch has a very low viscosity. So means that this is one of the properties of the Fischer-Tropsch wax, and this permit the viscosity to allow to help the benzoate to achieve the best result for degassing. Thank you, Sina.
Thank you, Luca. We have a couple of more questions. I think we still have time to answer some.
Yeah.
There's another interesting question I see here. Why have FT waxes better transfer efficiency than PE or other waxes?
Yeah. Also, this question is interesting. We checked that, and we checked that our Fischer-Tropsch wax can carry the charge through the spray gun better respect other boxes. So this permit or allow, let's say, to transfer more powder from the gun to the final substrate. This is important because you can save a lot of money, because you can spray, in this case, all the, let's say, a very high percentage of wax on the surface. So in this case, our Fischer-Tropsch wax can carry better the charge in the gun.
Okay, thanks, Luca. There's another question related to Sasol wax 0907. Why is Sasol Wax 0907 only be used pre-extrusion and not post-edit?
Yeah, so as you know, the Sasol Wax 0907 is a microcrystalline wax. The microcrystalline wax are, let's say, as I mentioned before, are a medium viscosity, but they are also sticky. So we have only we can produce only pasteurized version of this wax. So that's why if you see all the tests done in with pasteurized material, you can use only in pre-extrusion and not in post-extrusion. In post-extrusion, we use only the micropowder version that is needed to do that. And that's why we can achieve a very good result with Sasol Wax 0907, but only in pre-extrusion. So where if the customer can do the pre-extrusion, it's good to use the microcrystalline version, or is not possible to use in post-extrusion.
Great, Luca. It's coming more and more questions now during your explanation, which seems to be a good positive sign. So let me still continue asking some. Here's one. Why wax helped to degassing?
Yeah, as I mentioned before, the wax, I mean, the Fischer-Tropsch wax is, as I mentioned before, as the Fischer-Tropsch wax has a very low viscosity, a molecular mass from 750 to 2,500 Daltons, and this viscosity help a lot and allow for an easy degassing. So means that they help the system to bring the bubble outside on the surface. That's why in a liquid phase, the Fischer-Tropsch help a lot to allow to bring all the bubble outside.
Perfect. And there's another question. Can I use less than 1% of wax?
Yes, of course. As I mentioned before, 1% is the standard. So means what Sasol suggests for all these tests with this formulation. Of course, there are some possibility to use less percentage of wax, probably in post-extrusion, respecting pre-extrusion, or again, if we change the formulation for the three technology, as I mentioned before, for the epoxy-polyester based formulation, for the HAA cross-linked, or for TGIC, sometimes we can depend also from the type of the wax. You can use less, 0.8, 0.7%, or you need to use more, 1.5. Depend of the situation and depend also from the formulation itself. In this case, if you remember, with the epoxy-polyester resin, we use a combination of two polyester resin, a carboxylate one at 36% and a solid epoxy resin at 36%. If you change also this parameter, if you change also this percentage, in this case, you need to test with other percentage of wax. Can be less, can be more.
Thanks, Luca. Okay. There's another question. Maybe you can answer on that. What kind of metal did you test on?
Yeah, we tested on aluminum surface. And again, this was we decided to test and we decided to use the same surface for all the tests, because what was standard for us, and we decided to put more effort possible on the wax and not on the other parameter. That's why we use the same. This could be another question that can come. Why you use the same polyester resin for, in this case, Alnex, for example, for all the formulation? Because Sasol decided to put the focus on the wax and not on the other parameter or on the surface, or as I mentioned before, we use the same standard for the extrusion. We use the same standard for the flakes, for the micronization of the flakes, or for when we spray, we use the same gun and we use the same time in the oven, the same temperature. So we try to maintain the same parameter and the same surface, and only one surface for all the free technology, for all the tests, for all the performance to achieve, as I mentioned before, the 5 performance. So in this case, the sleep properties, the smoother properties, the matting properties, the transfer efficiency property, and the degassing helping.
Thanks, Luca. I would say another last question.
Yeah.
Before we end this session.
And of course, I want to underline that if there are, I'm pretty sure, because there was a lot of attendees, a lot of participants, for all the other questions that probably you have done, or Sasol will take the next 7 days to reply. So don't worry, that we will take care, and we will take care also to send you this presentation. Yeah, thank you, Sinan. Tell me.
Okay, last question. Can I use Fischer-Tropsch waxes for architecture and exterior powder coatings?
Yeah, this was not tested in this webinar for this, let's say, for this section, but we have a future webinar, future section that we will show also to you the performance of our Fischer-Tropsch wax and also microcrystalline wax on other surface with other parameter involved. Let's say to you, I want to underline you for again, because it's important that we try for this test, we try to maintain the same standard and probably, yeah, this also the same surface. So probably if you send me an email or you send to Sinan from Prondisky an email, we can explain to you also the performance on other surface with other parameter involved and with other percentage of wax.
Okay, Luca, thank you very much for this great presentation. Thanks to the audience to all these questions. Yeah, I repeat again what Luca already mentioned. There are some questions maybe which has not been answered. We are pleased to answer them after this presentation in a one-to-one contact maybe. Besides that, again, you will receive this presentation or at least a link to the content so that you will have time to explore a little deeper and also come back with certain feedback and questions, of course, afterwards. We are looking forward very much to your comments and, of course, if you attend also our next webinar. Thanks a lot. Take care and all the best. Bye.